In today's video, I am going to talk about how to find equation of plane in normal form. In the first part of the video, I have shown what is exactly the 3D diagram of the plane. Then I have drawn the diagram, and we will be understanding how to draw this diagram, what exactly the meaning of this diagram, and I have done the all calculations step by step. The equation of plane in 3D form, and I have drawn the same diagram on the plane of paper. We are going to understand this today in this video, as well as do and learn step-by-step calculation to get the vector equation of plane in normal form, as well as Cartesian equation of plane in normal form. So let us start today's topic to understand to get the equation of plane in normal form. In three-dimensional system, there are the three axes. All the three axes are perpendicular to each other. Angle between every two axes equals to 90 degree. So this is x axis, it is y axis, and it is z axis. So there are the three axes in three-dimensional system. And the same diagram in our textbook, in our notebook, we can draw by taking x-axis, y-axis, and z-axis in this way. This is a plane now, and we want to find equation of this plane. Equation of this plane in normal form. Now question is, where to place this plane? Where to fix this plane? So answer is, we can fix the plane anywhere. Here in this diagram, I have shown different positions of the plane. Plane has taken different positions. But while finding the equation of the plane in normal form, you have to fix at one particular place. After fixing, while finding the equation in normal form, you cannot change the position. If you change the position, then equation will also change. So to understand how to find the equation of the plane in normal form, let us fix the plane at particular position. If you change the position, you will get different equations. That means for different positions, different equations. So now let us fix the plane at particular desired position. To find equation of the plane in normal form, now what I am doing, I am fixing the plane at one particular position. And this is the plane. Now I have fixed it. It is cutting all the three axes. It is cutting x-axis at the point A, and y-axis at the point B, and z-axis at the point C. In textbook, the same diagram is drawn. That is the point A on x-axis, point B on y-axis, and point C on z-axis. Now this is the plane. This is a 3D diagram, and this is the plane. But in our notebook, we cannot draw the 3D diagram. So we draw this plane in our notebook in this way. Join A and B, join B and C, join C and A. So this is what the point of intersection. We are joining the point of intersection to get the plane. So this is the plane. Here in 3D diagram, I have shown by the white color. Cutting at the point ABC. I just joined A, B, C points here. So I got a plane. One more important point. You can extend the plane, length of the plane infinitely, indefinitely. You can extend it. So we can extend the plane to any length. Length is not important. Length can be extended infinitely, breadth can be extended infinitely, but the thickness of the plane must be negligible. It is very thin. So thickness is not important. Only length and breadth of the plane are important. So here it is not very important to know what is the length of the plane. The important thing is that the plane is present in the three-dimensional coordinate system. I am trying to correlate this 3D diagram with the textbook diagram. Both diagrams represent the same thing. Now on the plane, I take a point. For example, point P, and coordinates of point P are x, y, z. Similarly, in this diagram, this is the right side. Right side diagram is generally this diagram found in your textbook. So I am selecting now point P on this plane x, y, z. Both diagrams are same. One is drawn with the help of 3D. Another diagram I have drawn in the notebook. Now joining the origin and the point P. Here also joining origin and the point P by a straight line. So O is the origin. Now draw a perpendicular from plane and joining the origin. So I have drawn a perpendicular. This perpendicular can also be called as a normal. So drawing this normal here and call this point on the plane as a N. So this is a point N and it is a point N. Now we have the two things. We have vector OP and we have vector ON. Vector OP is nothing but position vector of the point P. It is a position vector of point P. And ON nothing but position vector of point N. And position vector ON is called as a normal vector. We are going to obtain the equation of the plane by using this normal. Therefore, it is called as a normal form. Now, join N and P by a straight line. N and P, the straight line. The line NP lies on the plane. So, line NP. It is also a vector. It lies on the plane, and angle between vector ON and NP is 90 degree. That is, vector ON is perpendicular to vector NP. Vector OP is the position vector of point P. Let us call vector OP equals to vector R. That is the position vector of point P. And vector ON is nothing but vector N. Let N cap be the unit vector, unit normal vector. Since vector NP perpendicular to vector ON, both are perpendicular to each other. Therefore, the dot product of NP and ON must be equal to 0. Whenever two vectors are perpendicular to each other, their dot product is always 0. Now, how to find out vector NP and vector ON? That is the next target. Now, complete the vector diagram by drawing arrow marks. Now, we got here the triangle we got here the triangle ONP, and from this triangle, the addition of vector ON and plus NP equals to vector OP. This relation we obtain by using triangle law of vector addition. From this relation, we get vector NP equals to vector OP minus vector ON. Now, let magnitude of vector ON equals to D. Magnitude means magnitude of vector ON means what? Magnitude of vector ON is nothing but length of vector ON, and unit vector along ON is nothing but n cap. So what is n cap? Unit vector in the direction of vector n is nothing but n cap, and we can represent vector ON in terms of unit vector, that is D multiplied by n cap will give you total vector ON. Therefore, vector NP can be written as vector OP is already vector R, and vector ON we got here is nothing but D n cap. The vector ON can be written as D multiplied by n cap. Since we have the dot product of vector NP and vector ON equals to 0, vector NP we just got it, that is vector R minus D multiplied by n cap. This is the value of NP, vector NP, dot product of vector ON. ON is nothing but vector n. So here writing vector n equals to 0. So this is the equation of the plane in normal form. We can simplify this equation further. Vector R minus D n cap, and outside vector n can be written as D multiplied by n cap, where D is not equal to 0. Therefore, here D n cap equals to 0 implies vector R minus D n cap dot with n cap equals to 0 divided by D. D is taken that side. Now opening bracket, so R dot n cap minus D n cap dot n cap equals to 0. We know that A dot B equals to AB cos theta. So n cap dot n cap equals to n magnitude of n cap multiplied by magnitude of n cap, and angle between parallel vector equals to 0. Therefore 1 multiplied by 1 equals to n. Therefore n cap dot n cap equals to 1 implies, therefore vector R dot n cap minus D multiplied by 1 equals to 0. So vector R dot n cap minus D equals to 0 is equation of plane in normal form. Equation of plane in normal form. In textbook, it is also written as vector R dot n cap equals to D. Both the equations are one and the same. So in this way, we obtain equation of plane in normal form. This is the equation of plane in normal form, and it is a vector equation because it is expressed in terms of vector. Therefore, it is called vector equation of plane in normal form. The same equation we can convert into Cartesian form. To find equation of plane in normal form, let us say vector r equals to xi plus yj plus zk and n cap equals to li plus mg plus nk, where l, m, n are nothing but direction cosines of the unit normal. Since vector equation is given by vector r dot n cap equals to d, putting these values of r here, are nothing but xi plus yj plus zk dot n cap, that is li plus mj plus nk n cap equals to d. Now taking dot product, we get lx plus my plus nz equals to d. So this is required equation of plane in Cartesian form.